All right. So my work was with Matthew Turk on AMR volume rendering. So you can't really see it here. I guess I probably should have made the picture a little bit bigger. But the goal was to take volumetric data sets of astronomical data. So think a big 3D array of a bunch of floating point values and be able to visualize them on the GPU and quickly. Because the YT project already has a pretty amazing volume rendering system, but it doesn't run on the GPU. So my goal was to make something using OpenGL on the GPU, and ideally give scientists the ability to edit the shaders in real time. So you could, have a window on the side where you adjust shader parameters as it is being rendered. So right now what I have is just the basic, very basic, what's going on. So basically we take a large 3D bounding cube where all of the data set is inside. And then for each block in the data set, we have another box. Then we pass rays through the box, looking at the values on our way through, and we pick the max value as the color for that pixel on the box. So right now it only supports the maximum intensity projection. Ideally, from here we use other projections. If you look at this box here, once again, you can't really see it. You probably can see it outside though. This is just a wireframe mesh. So each one of these is just a box rendered with simple triangles. And as you can see, where the data is more precise, you have smaller boxes. So one of the other things that this allows us to do is that as you're passing the ray through, you can change the ray's step size depending on the volume of the box or the size of the box, so that if you want more precise increments in smaller boxes, you can get that. One of the problems we had though is, so it turns out that you have to be very careful when you're passing these rays through, that the directions are very precise. So recently we just fixed some of the artifacting issues that we were having because we were interpolating the directions of the rays rather than getting them per fragment. And that's some OpenGL specific stuff that I can go into if anybody's interested. But it was a really cool problem, and I'm probably going to talk about that bug for a long time. Some of the questions that we are looking at is how can we ensure that we can use the trilinear interpolation that's given to us by the GPU for free across the box boundaries? Because right now we're only loading one box of data into the GPU at once. So ideally, something we're thinking about right now is being able to load as much data into the GPU as possible and then interpolating across the different boxes, either with something like a texture atlas or something like that. I'm not really sure on the details, but something that you have to be very careful with that is not running out of GPU memory or anything like that. Making sure that we maintain some semblance of real time would be great, even with really large data sets. The frame rate stuff was difficult to keep fast, mainly because we were loading so many different textures. Ideally, if we can load as much texture as possible, that would really increase the speed. And then long-term goal is adding that dynamically changing the shaders and allowing scientists or whoever is using it to change the rendering style on the fly very quickly. And I guess that about sums up all I really wanted to say. Any questions? Oh, I keep on hitting the microphone. Sorry.
Did you do any performance tests between the GPU version and the CPU and GPU versions?
No, I was kind of scared too, because I was afraid that
it might be slower.
Yeah. So I honestly do think it is a little slower in some cases because each small box here that has data is being loaded in as a single texture, and they're being done one at a time, not in parallel. Ideally, from here we can load them in as that texture atlas and do them in parallel, and that would increase the speed. But yes, at the moment, it's not, I haven't tested it yet, but I wouldn't be surprised if it is a little faster. Just
So it's going to have more features? Is that then I missed the point. If it's not going to be faster, it's...
Well, the goal is to become faster, and it can become faster. It's just right now it is not due to...
and then do you have a model of the theoretical performance that you're after?
Real time for moderately sized data sets would be great.
But I mean, in terms of what the GPU could theoretically do, is there a way to measure the performance against the peak performance of the GPU unit? So
the GPU could potentially do much, much, much better, because the CPU right now, even on a multi-threaded machine, is just, you think of a standard multi-threaded machine, you can't do several rays at once, while the GPU is doing all the rays all at the same time, because each single ray is being computed as it's in the fragment shader, and you have all of them there at once. So theoretically, much, 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 much faster.
Okay. That sounds like several orders of magnitude faster.
Yes.
Yep. Okay.
Hopefully.
So in order to make an image, when you're loading one brick at a time, so you shoot the whole image full of rays for that brick. Is the idea something like you would use the tree arrangement to sort the bricks by depth, and then shoot all the rays for one brick, and then load the next brick and shoot all the rays again and composite at each?
Yes.
Is that what it would do?
That's what it's doing right now.
So
yeah.
you'd end up shooting lots of rays that didn't intersect the particular brick you had loaded, but
Exactly.
they wouldn't. Okay, good, thanks.
Yep. Anything else? Okay, great. Thanks.